So this one part right here where we finished up, I was showing you the graph of the left side of that equation, which is right there. So the absolute value of x plus 2 minus the absolute value of x minus 1, that's the graph. I don't know that anybody would have predicted that that would be the graph, but it turns out that's the graph. The equation was when is it equal to 3? And so it's not equal to 3 here, it's not equal to 3 here, and right there all of a sudden it becomes equal to 3, and sure enough it's equal to 3 forever, right? So our solution, and again, you would not graph that or sketch that or anything if you were solving it on a quiz or a test, I don't think. If you're working at home, I think it's an awesome idea. If you have GeoGebra or Desmos are both really good graphing, free graphing software online, and you can very quickly graph whatever you want and look at it to help understand your solutions, your answers. But it's not necessary for a quiz or a test. In fact, you won't have technology and graphing them would be hard. So why do we do it? Well, because it does help us interpret our answers and make sense of them, and then we get used to the different kinds of answers you could have, but we want to just solve it algebraically. And we want to be able to interpret our answers algebraically as well. And again, this is something that starts in grade 10, where you get an answer like this, 3 equals 3. What in the world? Of course 3 equals 3. How does that help us? But the visual of the graph then helps us interpret, oh, I see. So this is always true. So therefore, in this entire interval, when x is greater than or equal to 1, it's true. And then we also noticed that included this answer, so do not list those as separate answers. A person who lists these as separate answers is doing a great job, but it does show me or whoever's looking at their work, the marker, that they're kind of just going through steps. Like they get this, check mark, okay, I listed as one of my answers. Check mark, okay, I listed as one of my answers. Versus somebody who thinks about it and says, hey, wait a minute, this includes that. Why would I write it twice? I hope that makes sense to you, because that's important. That's just like difference between a level 4 and a level 4 plus kind of thing, right? So keep that in mind. You really do want to think about all yours. This one on the left here is also a great example of the other kinds of things that happens. And that, again, you don't necessarily need to know why, but this happens because the line 3 that we're comparing it to, which is up here, is parallel to this, so they will never cross. Right? It's not like they cross, but they cross outside the interval, so the answer doesn't fit the interval. They'll never cross. And that's what we end up getting, just like in grade 10, 0 equals 6, or 1 equals 2, or 5 equals 10. You get something that's just not true. It's nonsense. It's silly. Okay? Any questions about that? Now, I want to show you one other thing before we move on. So why does the graph look like this? I know I'm kind of a broken record right now, but again, you don't need to be able to do this. But I just think when you were talking about, it's a functions class, this is the whole point, is how does the algebra relate to the function? How do the functions relate to each other? So take a look at what this is. So the graph on the right, the orange graph is x minus 1, the absolute value of x minus 1. And this is the absolute value of x plus 2. So those are the two ones that were on the left side. And it's one minus the other. So it's this one minus this one, right? So if I line these up, what is the difference between these two right here? So this has a value of 3, and this has a value of 6. So the difference is 3, but we're doing the smaller minus the bigger. So the answer is going to be negative 3. Follow me, kind of? Like I'm looking at the y values here. Or let's pick another one. The purple is 5. So 5 minus 8 is negative 3. Do you see what I'm saying? So the difference between these two is negative 3 all over here, right? And the graph that we looked at before is the difference between those two absolute values. So see how it's, because they both have that same kind of slope, the distance is static. until, bam, you hit there. Then all of a sudden the distance gets shorter and shorter and shorter, becomes 0, they cross, and now the distance is getting bigger, positive, right? And then when it hits there, it's 3 forever. Well, look, that's that graph. It's -3, and then it gets smaller, becomes 0, starts getting bigger, hits 3, and it's 3 forever. Like, do you see how those things are related? That's functions right there to me. That's like our understanding of how the math works out and how looking at the graph, just thinking about it. Okay, what's this one? Oh, and then there's this one other really cool thing that we can do. But again, like, I don't know that this is something you have to do or that it will help, but if I take this and rearrange, what if I rearrange it to this? Equals, so I move the negative absolute value over to the other side. Now this is the absolute value of x minus 1 plus 3. Well, I have some understanding of what that is from grade 11 just using transformations, and we certainly know what that one is. So this one is going to be a shift right 1 and a shift up 3, and watch what happens visually when I do that. I want this one and this, nope, I want that one and that one. So now the blue graph we had before, but the purple graph is my new one. And look, at x equals 1, they become the same graph and they will be forever. So again, I did some algebraic rearranging, but the visual still works. Like, do you see how the algebra and the graphing match? Like, they're the same thing. This is the visual of it. Now I have two different looking functions, but the solution's still the same. Anyway, it's just kind of interesting to look at this stuff. All right, enough of that. Any questions before we move on? The answer's still the same. Interpreting the answer is really important. Okay. So this is a double absolute value equation. There's two absolute values. That means we have to look at 3 different cases where the intervals overlap, where they're both negative, where one's negative and one's positive, and where they're both positive, right? So go ahead. I hope that you were able to do some practice and now you kind of can get these started. And I said this yesterday, if you're thinking about getting ready for the quiz, then you don't want to stress about these kinds with the double absolute value because they're not on the quiz. That being said, challenging yourself with harder questions makes the easier questions easier, right? So, like, doing these is probably a really good idea as long as it doesn't confuse you and then you try to do the other kind like this. The other kind only has 2 cases. This one has 3. So that's something you need to know. Otherwise, you're trying to use the wrong tool for the wrong job. It's not going to fit. It's not going to work. But otherwise, it's not a bad idea to do some of these harder questions to be ready for tomorrow. So I split up my intervals, and I was having a chat with somebody yesterday about this, and something that came up, I always use 0 as a check for in an interval, like for which one is, like these 2 I know are both negative, these 2 are both positive. It's not a bad idea to check them anyway. Check 10, something big, or 100, something big in this interval. Toss it at both of them to make sure you get something positive. Negative 100, right? Negative 100 times 2 is negative 200 plus 5. That's still negative. So definitely both of those are negative. and then check something in here. But you can't check 0 here. Like, you can't always use 0 in the middle interval. You have to use a number that's in the interval. 0 is at the, you never use the edge of an interval either. Okay, so don't use 0 in this case. You'd have to use -1 or something in this interval to check which of these is negative. Because if it's negative, I multiply it by a -1. That's what absolute value does. Remember, back on that first date, if the function's negative, we multiply it by -1. That's essentially what absolute value does. So when I'm writing this out, they're both negative. I take the function, which is 2x plus 5, and I multiply it by a negative. Right? That's how we account for that. That's why we're splitting this up into our cases. And then you just solve. So for this interval, -5 over 2 is less than or equal to x less than or equal to 0. I'm only multiplying one of them. By negative, and in this one, neither of them. So what happened here? Let's interpret this. Take a look at our solution. Hopefully you got the same thing that I got. Something weird going on here? Like, so this is, hopefully that's the easy part, doing the linear stuff. Remember I said yesterday, we all make little careless errors with the negatives and stuff like that. Sometimes because we're rushing, we're worried about something else. Don't, right? Like, make sure you get this right, because if I put a question on a quiz or a test that's meant for you to interpret in a certain way, and you're supposed to show me that you can do that interpretation, if you get this wrong, well, everything's out, right? Because then you don't even have the opportunity to interpret it the way I was hoping, or probably. So you really want to get this right. So it doesn't take that long to show a couple of extra steps. Make sure you get the right answers. What happened here? This is probably the hard part.
All of the answers we got don't fit within the domain that we wrote out for ourselves.
And you think we did everything right?
Yeah.
Because I think somebody might get this and be like, I must have made a mistake. Because this one doesn't match, right? -1 is not less than, what is this? This is -2.5. -1's not less than that. -3 is not in this interval because it's less than -2.5, so it's still outside. And this one's definitely not greater than 0. What? We didn't even get one answer? Well, again, let's look at, there it is. The absolute value of 2x plus 5 plus 4 equals the absolute value of x. It says 1x, but look, they don't cross. Look at that graph. They're not going to cross. So our answer fits And when I look at these, like I'm not sure you could do this in your head. If you're getting really good at this kind of visualization, some people are, some people aren't. You might be able to, but this has like the 2x gives it a steeper slope, and the +5 +4. So I'm shifted over and I'm shifted up quite a bit. And this one's not as steep a slope. And so as long as that bar kind of misses this point, it's not going to cross. But again, we want to have faith in our interpretation of the algebraic solution because we're not going to be able to sketch these, graph these every single time. So this does not work. Okay, not a solution. Does not work. No solution here. And no solution here either. Therefore, no solution. Yes. Yeah, for sure. Yeah. That's a standard sort of short form for solution. Okay. How is this question different? 2x. Visualize that. Take a look at those graphs. What happens when I make one of them 2x? What's going to happen here? So we could go ahead and solve this. Maybe I should just have the solution done. But like, what do you think might happen? It's hard to say for sure, but this is going to change. Watch, this is going to change. See, change the number here to 2. When I drag it over, we're going to get a solution. We're going to get 1. And then we're going to get other kinds of, like in the other intervals, you're going to get other things that you'll interpret in a certain way. They'll look different and they will not be solutions. Right? And then our other example, maybe we'll do one more of these just for practice. But our other example, how did this one change? Instead of up 4, it moved down 4. So visually, what's that going to look like? So I'll put this back, but now I'm going to move this down 4. So what's going to happen? Yeah, you're going to have 2 solutions. It's going to cross twice. And then you're probably going to end up with some other kind of, like you're going to get an answer, but it won't be in the interval. Again, you don't have to know algebraically why, like, so for example, this doesn't fit the interval. So it's not a solution. That's different from this one that's not true. We didn't get an answer that doesn't fit. It's not true. You don't have to know like why one is one and one's the other. You just have to know that both don't work. That being said, there is a reason. Like there is a visual. 2 parallel lines are giving us 1. And that idea of if I extend a line, they'll cross again. So if I take this guy here and I extend, look, it's going to cross through twice more again. Right? So that idea is different. But in the end, all of them are no solution. That's what we need to know. Any questions? I think I'm going to stop there. I think that's enough examples. So that one's just going to work out the same kind of way. But questions?